Welcome to lesson 4.1. Actually, welcome to chapter 4. We're going to be talking about rational functions here. Rational functions in general just means, well, what's a ratio, right? Or what's a rational number? Rational number is one that can be written as the ratio of two integers, right? So, in other words, you're talking about fractions, right? A rational function is a function that has is a fraction. So essentially, you would have variables in the numerator and denominator. That's the key for something to be a rational function. So the first thing we're going to look at here is what's called inverse variation. So how do you determine if a relationship represents an inverse variation? So the question is, you got a table here. Do those values represent inverse variation? An inverse variation is a relation between two variables such that as one variable increases, the other decreases proportionally. So if you find the value of x, y for each column of the table, they should, if it is inverse variation, they will remain constant. So that's what you're checking. So again, here's another table. As x goes up, y goes down. So that part holds. But when you figure out the x, y, is not constant. So this is not inverse variation. There are two you try it questions where it's just you're given a table, figure out what that x, y column is. If it's constant, it's going to be inverse variation. If it's not, then it's not. So give them both a try and then come back and I'll go over both of them with you. All right, so pause it now and give it a try. So for 1a here, each time I did x times y, I got 25.5. So that means, yes, this is inverse variation. All right, let's give 1b a try. So same thing, give it a pause and come back and check. And then this one is an example where it is not inverse variation because it is not constant. Every one of those numbers is different. So the answer is no. Let's look at example 2.